Thank you all for coming, and thanks for your hospitality. It's a great pleasure to be here. It's first time for me in St. Petersburg.
У нас в Москве еще народ не собрался.
First time in Russia, first time at Yandex. So it's my pleasure. I wanted to thank in particular Alexander Shubin, who organized much of my trip. And Alex and I have been collaborating for over a year now as part of the schema.org effort, which I'm going to talk a bit about in this presentation. Okay, so as it was mentioned, my name is Mika. I work for Yahoo Research. Yahoo Research is the research arm of Yahoo, the internet company. We are actually a worldwide distributed organization. We have offices across the world, starting from California in Sunnyvale, where the company is headquartered, to South America, 2 locations in Europe, in Barcelona and in Haifa in Israel, and then in Bangalore in India, and in Beijing in China. So these are the research offices around the world. Okay, so in this talk, I'm actually going to be fairly brief. I want to give some time for discussions, and also I'm sure you have a very mixed set of interests. It is going to be a bit introductory. Many of you, I understand, are not working in the field of the semantic web, but maybe would like to know what is it that we are working on in this field. So what I'm going to tell you a little bit about is, in terms of motivation, is a recent development that we see across basically all search engines.
Вас не слышно совсем.
Okay. Shall I continue? Okay. So this trend is essentially the convergence of the search and the media business, in a sense. Search is not so much about just 10 blue links anymore, but it's about trying to answer people's questions and trying to help them in solving their tasks. So I'm going to talk a little bit about that, and then tell you some of the technologies that are sort of emerging from the semantic web and that search engines are starting to make use of. Okay. So more than just 10 blue links. I mentioned this, but we did start with 10 blue links. Instead, we started with many blue links. Yahoo as a company started to organize the content of the web by collecting links. This was the time before search engines. This was the time when the way to discover something was by talking to your friends, much like Facebook today, or going to the website where someone else collected a bunch of stuff and organized it for you. Now, of course, this was a very important service at the time, but Yahoo, of course, search engines came. Yahoo also started building indices on these links, right, and allowing people to actually search over the content also of these web pages, and then started slowly to add additional services. So much like Yandex has started as a search engine, Yahoo has diversified from that business quite a bit. So you probably know that the homepage has evolved. It has evolved to something very colorful that is actually just an entry point. It's an entry point to a multitude of services. We have mail, right? So we're one of the largest free email providers in the world, but we have other services such as finance, which is the #1 finance site in the US and in many other countries. But also other verticals. So I could mention here movies, entertainment. So a lot of these pieces that add different types of content to Yahoo. Okay, sports again is a very important bit. Okay, so we diversified, right? We went from 10 blue links to a host of vertical services. We do this not only in English, of course, but we do it in other languages, right? So this is Yahoo Japan. This is Yahoo 7, which is a joint venture in Australia. And of course, we have a website in Russia as well. So search at this point is more than just searching HTML pages, right? It is really an entry point to content, content that is on the web and content that we as Yahoo add to the search result page. And that you can see clearly. If you do a query in this case, for example, I search for Vienna, Austria, I not only get the 10 blue links, right? The 10 blue links are still here, right? Somewhere starting here and starting with Wikipedia. But of course, you see a lot more things going on. For example, we understand your query, Vienna, Austria. We understand that it's a city, and it's a city of Vienna in the country of Austria. So we can actually recommend you related points of interest in Vienna, things that you might want to see or visit. So you see these little pictures, and you see a list of points of interest. And again, this kind of related entity suggestions vary depending on your query, depending on what you're looking for. We also have these kind of information boxes, right? We call them direct displays, but people call them in different ways, which are again trying to answer the user's query directly. So in this case, this information box contains some information from Yahoo Travel, which is our travel vertical. And in particular, it gives you hotels, restaurants, flights, and again, some top-rated things to see in Vienna, right? And you might even know that we are actually not in the business of ranking these 10 blue links anymore, right? So our business is actually to put together this page for the user. And this is not just us. So if you look out to what other people do, if you look at Bing, if you type in something like digital camera, you don't see 10 blue links anymore. Instead, what you see is actual digital cameras. And that's what you want in the end, right? You don't want to see documents anymore. You want to see objects. In this case, the object that you might want to buy, right? And of course, the interface changes, it adapts. Now, these are not only the regular sort of facets that you would see in web search, but they are specific to this e-commerce domain. So you can restrict by price, by brand, etc. Okay. And you see this also in Google. So they have a box which is fairly prominent, and this box is filled with something that they call the knowledge graph, which is essentially a database of knowledge regarding certain notable entities. They acquired a company called MetaWeb, which has been building this online encyclopedia, starting from Wikipedia and starting from the information that is in Wikipedia, but extending it further and structuring it, right? So in this case, you search for Frank Lloyd Wright, the architect, and you would see some of the structures that he has built. So again, you see a similar pattern that depending on the user's query, the suggestions for related entities and related information might change. It is fairly prominent. So in Google, this takes up actually a fair amount of the search result page. But interestingly enough, I would say that search is not only in search anymore, right? What we have is essentially search everywhere, right? In this case, what you see is Yahoo News. Yahoo News is a news site, right? So we purchase content, license content, but also we create some of our own original content, and we present articles to the user. This is one of the article pages where you see some of these words that are underlined. So these are sort of important concepts, topics that have been recognized in the text. This is partly automated, partly editorially curated, and what happens is that if you hover over with your mouse, you hover over one of these underlined links, you get related articles related to that concept, right? So this is again some kind of search that is not even explicitly typed in by the user or triggered by the user, triggered only by the fact that the user has browsed over that link. Okay. And then what you see is, again, another form of search. In the case of aggregation, we build a number of sites that are aggregating content in different ways. In this particular case, this is Yahoo Local, where we collect and aggregate content for particular geographic locations. This is what they call hyperlocal, right, content. So content at the level of individual neighborhoods. In this case, I think it's Brooklyn Heights in New York. So you see the news again, you see events, things to do, you see deals, things you might want to buy. And again, if you just think about this, this is nothing more than just another query, right? And the query here is, give me everything that is relevant to this particular neighborhood, right? Just another dimension along which you can slice and dice your content. I mentioned that we do all kinds of aggregations, and that we do a lot around events, right? So when something important happens in the world, for example, this was World Cup, in South Africa, we do put out a special website or like a special microsite that essentially now aggregates content that is relevant to this particular event. Other events, so the royal wedding, of course, happened, I don't know, a year ago, 2 years ago. Again, it was an important event. A lot of people were interested in it. So our company created a specific destination site, right, where you would go if you would want to know everything about the royal couple. And this is an Australian example. So there, of course, they're really crazy about rugby. So this is the Rugby World Cup site. Okay, another element that is happening in search these days, and you may or may not realize to the extent that it's going on, is personalization. This is the Yahoo homepage. Personalization happens here. These lead articles that are shown here are selected by a machine learning algorithm, which we call the content optimization and relevance engine. It essentially targets content using user history, what the user has expressed interest in the past, but also demographic characteristics, right? So think about age, gender, location, etc. And then many of you know this, but of course display advertising is almost always personalized. In that case, on our site at least, the users can opt out of this personalization. So if you don't want your ads to be personalized, you can choose not to have that. And the last dimension that I sort of wanted to introduce is contextualization. So going beyond the desktop and desktop access, we have initiatives around TV. So we have something called Yahoo Connected TV, where the context is that you're watching some show on your TV, right? Maybe in this case you're watching a boxing match, and suddenly a survey pops up or something where you can interact maybe with the show or with other people watching the same show. Okay, a similar initiative we have for mobile devices. The idea here is also that if you have an iPad, iPhone, and you install this application called Into Now, then this application recognizes what you're watching on your TV by taking a sound sample, right? So similarly to how Shazam works for music, this tries to detect what you're watching on your TV. Again, it shows related content, as well as letting you chat with other people watching the same show, things like that. Okay. Right. So just to summarize some of the motivation of why we're thinking about more complex form of search, other than just document retrieval, right? We want to provide answers, not just links. That's one of the key motivation. We have to use, in order to do that, we have to use data, structured data, not just text. And we have to do this over our own content, but also over the web. Now that is a big difference. We understand our own content. Understanding the web is a bit more difficult task, right? Understanding the HTML pages that someone have generated from some MySQL database and trying to re-engineer what that page might mean and what that data might mean is a much more difficult task than understanding our own content. We need to do that also because we want to do aggregation, right? We cannot just aggregate parts of HTML pages. We need to understand how different content relates to individuals, to events, to locations, right? In a hyperlocal case, and other types of entities. And we need to do this to be able to create topic pages around entities, but also entire new websites around certain domains, right? Certain interest areas, like the royal wedding or like sports events. And we want to do this in a personalized and contextualized fashion. So what is common to this is that we have a need for a more advanced understanding of both the web and our content. And that's where the topic of semantic web and semantic search comes in. Okay, so we are switching gears a bit. Let's look at what our technological options are. What we have here as an example that I put here is an image of the Jeopardy game. This is a quiz show in the US. IBM created a computer called Watson to play this quiz show. How many of you have heard about this? The Watson, okay. Have you watched Watson playing? Have you watched no, okay. So it's interesting to watch. It is very fast, right? So it is faster than the humans. When it is right, of course it buzzes faster, right? It presses the buzzer faster, and it wins by that. But when it makes mistakes, it makes really horrendous mistakes. The example that I give here is a question which asks for the name of a city. It has to be a US city, so the category is given. And it's a city where the largest airport is named after a World War II hero, and the second largest is named after a World War II battle. So this is Chicago, where the two airports are O'Hare and Midway. So the right answer would be Chicago. Now, of course, the machine says Toronto, which is not the right answer, right? But I think the bigger problem is that the machine doesn't know why it doesn't know the answer, right? It doesn't know, able to explain why he thinks the answer is Toronto. This is a very sophisticated retrieval algorithm. It is the state of the art in question answering, if you want, which is an advanced form of search. It's an advanced form of search that takes an entire natural language question as an input. It applies very sophisticated natural language processing, information retrieval techniques, advanced machine learning to combine the input from a number of sources. But in the end, when it comes to an answer, it is not able to tell us why that the answer would be that. In general, this is the picture that we have of search today, right? Improvements are harder and harder to come by simply because we have exploited the trivial options of improving search. We did invent a lot of features of documents, of text documents that we can use to rank documents. We did look at the HTML page structure. We did look at how we can exploit links. That was, of course, the big innovation of PageRank. And then we learned how to combine these features, right? So we applied machine learning to learn to rank, right? Based on editorial judgments, or based on how users are clicking the results. We have invested heavily in computational power, and that, of course, improves search. Interestingly enough, I think these studies were done at Google, where they experimented with introducing different delays in displaying the search result. And sort of the finding was that users associate delay with lower quality, right? So if something loads slower, the users assume that the results are worse, right? Even if you show the exact same results, right? And there is no rational basis for this. For the users, there is simply this association between speed and quality. That is, of course, the reason why everyone has invested so much in data centers and in general speeding things up. We got to the point, of course, where we can do real-time indexing, things like instant search, right? So we search faster than we type, right? It cannot be faster than that, because then we couldn't even be able to see how fast it is. But I would say that the remaining challenges are thus not computational, but they are really related to how we understand the query, how we are able to recreate the interpretation of the query that the user had in mind when writing down those few words, very few words. And you know, I would say that that is critical, right? So we can say that, you know, we consider our information systems and our machines intelligent to the extent that they are behaving the way we are behaving, right? So in that sense, understanding how we think and understanding how we act is very, very critical in building an information retrieval system. And of course, if a machine would be able to actually provide some rationale why a certain result would be the right result for a question, and that is only possible if, of course, the machine understands the question and it understands the answer and the connection between the two, then of course it could provide an explanation the way current search engines are not able to explain their results. The question then is, of course, how do we teach the computer about the world? And that's one of the questions that the Semantic Web community, and in particular, you know, the hardcore part of the community, knowledge representation and reasoning community, have thought about, right? How do we represent knowledge? How do we represent conceptual structures for a machine, so that the machine can do computation, reasoning using these structures? Okay, and if you look out on the web, of course, we might want to get some help in this, right? We might try to recreate the interpretation of a document by trying to process it, by trying to parse it, by trying to extract something from it. But we might also enlist the help of the webmasters, the help of the publishers who are putting out the websites, in helping us to understand what the content is about. Okay, just very quickly, you know, it's not just search, and in fact, search works often much better than online advertising. What you see here, I was searching for the name of a colleague of mine. His name is Roy Blanco. The web search results are pretty good, right? However, the advertisements are horrible, right? There is apparently a type of sync called the Blanco sync. Now, obviously, my colleague is not a sync, so that's not a very good result. I also get advertisements for holidays in Rio de Janeiro. Obviously, there was some spell correction going on here. We went from Roy to Rio, right? And same below here. There's also an advertisement for a Kia Rio. Now, for a human, it's very obvious that, of course, this query cannot be all of these things at once, right? These are four very different things. But still, you know, the way things currently work, and the way, you know, that these are textually actually similar, all similar to the query, this is actually a state-of-the-art result. Okay. So, I think to understand, you know, what people in the Semantic Web are trying to do, it's instructive to think about what it's like to be a machine, right? And why a machine is different from us, right? So if a user comes to us, they might have an idea. They are looking for this person, and they might type in some query to be able to find some information. Typically the name, right? They give this name to a computer, right? And the computer, of course, has a number of pages to choose from as to show as a result. And it does some ranking on top of these pages. Okay, but this is not how the computer sees this problem. The computer doesn't understand this, right? This is just a set of strange characters that someone gives you. There are some other things which are also just strange characters, right? And in the end, the best thing you can do is to match these characters to subsequences of those results above there, right? And that's how the computer sees the world, and that's how it needs to solve this problem. Okay? And that's why this is a difficult problem without further help, without someone actually telling you what this thing might be and how that thing might appear and be related to in these results. Okay, so people in the semantic web community have been thinking about these problems. Of course, the applications are different, not just search, but I would say everything that people do in the semantic web can be explained somehow through the lens of search as well. The main goal in one sentence is to move from a web of documents where everything is just text and sequences of characters to a web of data or a web of entities, right? Where things have an identity and they can be related to other things that are mentioned elsewhere on the web. Now, there are two main architectural challenges in realizing this vision, right? One is coming up with some kind of formats for data sharing, so essentially sharing data across the web. There are, of course, many document formats that you can imagine, but we're looking for one that is fairly universal. And that's going to be a graph-based format, right? So there's this understanding that graphs are the data structure that can capture conceptual structures fairly well. And we are looking for ways to share the meaning of the data. So put it very simply, we are looking for some ways to create and share schemas across the web, to create and share understandings that a certain piece of data means something, right? That it can be interpreted in a certain way, and it can have certain relationships and consequences with other things. Semantic web is a research field, but also a lot of the actual realization of the technical work is going on inside the W3C, which is the Worldwide Consortium, and it's responsible for creating the technical standards of the web. So W3C has created some of these languages, and I'll briefly explain some of them. And of course, besides the research aspect, I would say another important aspect is that this is really a community, right? So people who work on semantic web, people who work on linked data, they take this vision to the heart, and they try to help the web move in this direction, where data is published in standard formats, where schemas are shared in standard formats. Okay, the basic data representation in this world is a graph. I mentioned this already. The format that the W3C has created is called RDF. RDF is actually the conceptual data model. It's the data structure, if you will, that defines that such a conceptual graph is essentially a graph between resources, right? A resource might be connected to other resources. In this case, this resource is connected to its type, but the type itself, so this identifier of a class, is just another resource on the web, right? And resources may have attributes, so I distinguished it by putting it in a different shape, and these graphs are essentially graphs where the nodes are either resources or literals, strings, explicit data types. So that's the basic data model that the W3C proposes for knowledge representation on the web. Now, a key thing, a key technical innovation here is that all of these things, all of these resources are identified by URIs. So just like URLs are used to address pages on the web, URIs, a more generic concept, is used to identify things globally on the web, right? So if there's a resource here, this is actually a full URI, just abbreviated for the purpose of presentation. And if someone else refers to that URI, let's say, in HTML parlance, links to that URI, right? We can globally reference both ends of this link, okay? And that way, people can publish data independently, right? That's the critical piece. So in this case, this person, Roy, might have some piece of information on his own homepage, right? Which relates to himself and may provide some attributes, may describe some attributes of him, but it may reference other things. It may reference the schema, which provides the interpretation to the data. The schema might live somewhere else on the web, another website, right? And again, someone who is actually looking at this document is able to follow this link to get this schema, to parse this schema, and understand that this is in fact a person. Now, of course, that relies for that person to either then know what that person is, or go even further and try to relate it to things that he does understand, right? So there is this grounding problem. At the end, of course, there has to be something that you understand, right? And you can also set links at the level of instances, right? So you might say, for example, that this person is the same as that person. In fact, these are just two references to the same real-world thing, right? And this is actually the same Roy. It's just some information published about himself somewhere else on the web, okay? And now someone putting together this information, a crawler, right, going out and actually following these links, is able to then combine these pieces of the graph, and in fact treat it as one global graph. Now, there are two major ways of sharing this data on the web. RDF has many different serializations or formats. There's a format called RDF XML, which is an XML-based format for putting RDF graphs on the web. But you can also put RDF inside HTML. And this is what I'm going to talk a bit more about in the next few slides. I'm going to talk more about this way of sharing data on the web because it pertains more to web search and our work that we do in search engine companies. So essentially, there's a history, of course, before RDF of putting data inside HTML pages or marking up HTML pages for semantics. Already, the very first versions of HTML had something called meta tags. These were information items in the header, right? So you could say something like, the author of this page is this person, or that you have certain rights to this document, and you could link to other documents, right? That might provide additional metadata. But at the time when this came out, we didn't yet have the standards to actually say what this thing is and what it means, and to have sort of a shared format for the schemas, right? So someone looking at this and saying DC author would not necessarily know what that means, and there's no way to look it up. Now, if this would have been a URI, right, as it is the case currently in the current Semantic Web standards, you could actually just follow this link and find out what it means to be an author of a document, okay? And same for instances, right? So there's a string here, but it doesn't necessarily have to be a string. Maybe it could be a reference to a description of this person, right, providing additional information about that person, and again, the description could refer to other description, and so on and so on. Okay, the first experiments that people have started, sort of pre-Semantic Web or the time when people in the Semantic Web community started to concern themselves with HTML, was something called microformats. Microformats are still out there. They're still popular in parts of the web. The idea of the microformat community was to, in fact, reuse some of the other existing HTML elements to annotate pages and to mark up information in pages with their meaning. It's an informal community in that it is centered around this website, microformats.org, and essentially there's no standards organization behind this movement. This also means that that of course there's nothing to commit to. There are no specifications, or if there are, they are rather fuzzy and evolving. On the other hand, it's a very low barrier process for people to share new microformats. Now each microformat is a way to mark up a certain type of object. Okay, so here are some examples. So there's a microformat called hCard. This would allow you to put information about a person or an organization inside a web page. So you would take your HTML page and you would just add some additional bits and pieces of information. I mentioned that they reuse existing HTML elements. The class attribute is of course widely used in CSS as well. But the original definition of class attribute doesn't say you can only use it for CSS, but that it provides some kind of type information. So you indicate that here this block will contain hCard information, and in fact you then mark up the individual attributes. So you say that this is the formatted name and the URL of a person. Or there you see an email, a telephone number, or a title of another person. Okay. Now microformats have certain limitations. What you can see is that the syntax is shared with HTML. So if you actually had the CSS class called vCard, you would have some kind of collision between the presentation markup and the metadata markup. You don't want to have that. You also need to, of course, from a search engine perspective, from a consumer perspective, it might not just be a search engine, but maybe a browser extension that is looking at this page. It's fairly difficult to follow these microformats, not only because they develop fairly independently, but because they don't share a standard syntax, right? So what I mean by that is the only thing that indicates that there will be some metadata here is this word, right? But there's a separate word, a separate block indicating word for each microformat. So just by looking at this page, you don't necessarily know whether it contains a microformat unless you know that particular format. There's a lack of formal schemas for these microformats, so that also means that you cannot extend a microformat, you cannot combine them easily, or reuse them when creating a new microformat. Compared to the semantic web way of representing knowledge, there's certainly no opportunity to give unique identifiers to things, right? So you could say that this is a person, but you cannot really give it a global identifier to which you could reference later, either from other parts of the page or from different pages. And then there are some technical limitations. It has to appear in the HTML body, so it cannot be in the head in this case. And as I already mentioned, things change fairly quickly in that world. Now, to give a better alternative, the W3C came up with RDFa. RDFa is already a W3C recommendation for embedding RDF data in HTML pages. So achieving similar effect to what you can do with microformats, but fixing some of the limitations that I mentioned on the previous slide. RDFa is a standard format, and that also means that you can write a single parser to parse RDFa data out of HTML pages, and that works independently of the schema. So that works independently whether that page is marked up for persons or organizations or recipes or events. I mentioned that that addresses these limitations and introduces some of the ideas that I talked about before, in particular unique identifiers and flexibility in also in how to use it. So head or body, you can put RDFa wherever you want. Okay. I mentioned that that's a W3C recommendation. The W3C also iterated fairly fast on this recommendation. So the first version came out in 2008, and there's a 1.1 version that went through the recommendation process, and it became a final recommendation this year. There are some improvements in this latest version, making it easier for publishers to alter RDFa. I briefly wanted to show you some RDFa examples, what it looks like compared to microformats. So this is the Facebook Open Graph format. I'll come back to that later. But essentially what you see in the markup is a definition of a namespace. So this is going to say that the URIs that start with OG colon, they are an abbreviation of this bit plus whatever comes after, right? So it's a prefix. This is markup in the head. This is this particular example, and it says that the title of this something is The Trouble with Bob, and its type is text, whatever that means, and there's an image associated with it. You see the advantage of URIs already in the sense that if someone doesn't know what this OG thing is, right, they can actually follow this link, go to a web page, and they'll see a documentation of what that means, right? And hopefully also a machine-readable format of the schema, right? So a machine-readable format of what are classes that are available, what are the attributes that apply to them, what is the range of those attributes, and so on and so on. It's not just the header, so RDFa can be in the body, and for example, it can appear on links, in which case, essentially, what you can achieve is giving a type to a link, right? So you might say that this document that this page is referring to is actually the license document to this page. It describes the license of the content. This is the way how to assign an identifier, right? So now you're saying not only that this block will contain some metadata, but it actually identifies this particular object. This is not a person in this case. This is actually an information resource, an image, and this image again has some title. It might have some creator, and so on and so on. Okay. And of course, you can talk about subjects, either things that appear in the page or things that appear somewhere else on the web. In this case, there's no about, so we don't know the identifier of this object, but we know the type, that it's a person, and it has a name, and it has a mailbox, and it has a phone number. If you're a webmaster and if you have some piece of content on the web that you want to annotate, what happens is that since you have a standard that is agnostic to the schema, first you have to choose a vocabulary or a schema that you want to use to mark up your page. Again, the schema will give you the types of objects that you can use, right? So the recipe schema that someone gives you might say that there are these 5 classes, there are recipes and ingredients and I don't know, something else. And the recipe can have a cooking time and it's related to some ingredients, and these ingredients need to be cooked in a certain order, and so on, right? So it gives you the attributes and relationships that you can use in the data. Now, as a publisher, then you would want to annotate your pages. Of course, pages these days are not handwritten, but the template of the code that generates the page, and then essentially there are some tools to help you do that. There are some content editors out there that support RDFa natively, and also tools to check your work, to validate your work. And then you put your annotated page online, and we'll come to this bit. Then, of course, the search engine might come by, might crawl it, index it, and then do something with it. Okay? Now, what are some of these things that the search engine might do with this data? So the first thing we started working on at Yahoo is what we then called the SearchMonkey project. This is a project I started in 2008, 2007. It launched in 2008, around May. The idea here was to use this markup to improve the presentation of search results, right? So while in the past you might have had title abstract URL, what they call the TAU of web search, we decided that we can use some of this data that people might put in their web pages to create a better presentation. So for example, if someone helps us to identify that this page contains a video, then we can actually put a video player in the search result page, actually allowing you to watch that video directly from the result page. At the time, we did this for a couple of types of objects, and we came up with the schemas ourselves, right? So we published these schemas. We told publishers, webmasters, where they can find it, and we gave them some tools. So we gave them code examples. We gave them a validator, so they could come to our site and plug in their URL, and we would tell them if we understood their markup, if we understood the information that they put into their web page. Now, this was fairly successful fairly quickly, in that our competition moved on to adopt some of our inventions, and Google launched rich snippets in May 2009, following on very much the same idea. But of course, publishing their own schemas and asking webmasters to now publish and annotate pages that contain the markup that they understand. Right? But the basic idea was very much the same. They used some of the information. Again, a different example. In this case, it's a review of a restaurant, where they use the star rating information from the page and the price range, and they display it directly in the search result page. Okay. Facebook again thought this was a good idea, and they would like to do this. So in April 2010, they announced something called the Open Graph Protocol. The basic idea of the Open Graph Protocol is, again, to help Facebook to understand what a page contains. It functions in the relationship to these like buttons that they invented more or less around the same time, and they started asking people to put these like buttons on their web pages. What happens is that when such a like button is clicked, then Facebook fetches that page, right? So Facebook is not a search engine; they don't have a crawl of the web. But at the time when someone clicks that like button on this page for the first time, right, they fetch that page, they parse it, they extract the metadata, so they know what that object is about. Now, what they do with it, at least what is visible on the site, is that they again generate some kind of a rich snippet in the news feed, right? In this case, and also on the personal profile page, right? In someone's about page. Because now, so in this example, someone clicked on a movie on IMDb. Now they know that they like that movie on IMDb, not just that they like that page, right? Otherwise, it might have just said someone just liked the page on IMDb. Okay. Essentially, what they did on technical level is, again, invent their own schema, right? In fact, they changed the URI of the schema a couple of times, I think twice, and they published the specification at that URI. And they suggested a couple of attributes that you can use to mark up your page for different types of objects. Now, of course, I will come back to that. But of course, the problem was that that again, this was not compatible with the suggestions of Yahoo or with Google. Okay, and things got a bit worse, also on the technical level. Worse in the sense of too many choices. In that W3C started working on another standard, another technical specification for putting data into HTML pages. This one is called Microdata, and the reason they started on this project is because they started working on the next version of HTML, this ephemeral HTML5 that will someday will be ready. Microdata is a companion specification on how to mark up web pages in HTML5. The markup looks similar, but unfortunately is not compatible. So the names of these attributes, item ID, item scope, item prop, are completely different from the attribute names that RDFa is using. Okay, so at this point, now we're somewhere in 2010, we are in a situation where there's just too much choice, right? There are too many ways to mark up your page. People are telling you to mark it up different ways. So if you want to comply with everyone, now you have to mark up your page multiple times. So there's enormous bloat. There is a huge chance that you will get it wrong, right? And that you mess up your page in some way. Right. Now enter the solution. So part of the solution we believe is a collaboration, right? And this is a collaboration that has been started in sort of end 2010, officially launched in 2011. This is a collaboration initially between Bing, and Google, and Yahoo, when actually coming together, agreeing on the schemas, agreeing on the formats that webmasters should be using to publish data on the web. This is a very rare occasion. So I have to say, the last time that these three companies collaborated was in 2006 before that. So I think such an opportunity comes by every 5 years when we managed to agree on something. 2006 was sitemaps, so I think most of you know what sitemaps are. But sitemaps was again a critical piece of infrastructure that did not come out from standardization, but was actually an agreement between the search engines. And in fact, the analogy to sitemaps is that with sitemaps you publish the structure of your website. With schema.org, the idea is that you publish the semantics of your website, what your content is about, not just where to find it, but what it is. Okay, and it is driven by the use cases that search engine have, and the use cases that typically people typically do with search engines, searching for organizations, people, videos, images, recipes, reviews, and a couple of other types of objects. This initiative has evolved quite a bit since the beginning, and already after a few months, we are very happy that Yandex joined this group, and in fact, it implemented or uses currently schema.org markup in a number of products. Okay. There was also evolution on the technical level. RDFa had this 1.1 work in the way and already going on, and they decided, inspired by sort of the needs of schema.org, they decided to create a lighter weight version of RDFa, which is called RDFa 1.1 Lite. And that's a recommendation since June this year. This is actually the subset that is required for this use case. W3C also started to task forces within the Semantic Web interest group. So this Semantic Web interest group already existed. The two task forces. One of them focused on the schemas, and this essentially became the current discussion forum. So if you want to discuss schemas, extensions to schema.org, tooling, this task force has a mailing list, public vocabs at w3.org, where currently the discussions are taking place. Then there was another group started which actually tried to figure out the relationship between microdata and RDFa, and this produced a number of interesting notes and documents that sort of try to bridge the gap between the two. What is going on in the schema.org working group is that we are also constantly looking at new extensions. So people come to the forum and propose extensions. We have worked on a number of these extensions relating, for example, to news. We worked with the IPTC, which is the standard organization of the news industry, and in collaboration with them, we adapted RNews to schema.org and incorporated much of the RNews vocabulary in schema.org. We also worked with Good Relations. Good Relations is the largest e-commerce metadata format currently on the web. It's supported by a number of platforms that people use to host online shops. Okay. And there are some other extensions that came from really different directions, different organizations that approached us, different individuals that contributed schemas. Now, if you go to the schema.org website, what you see is primarily a human documentation. You see, in this case, documentation of a class called local business. And just as you would expect, you see what are the attributes, in fact, what are the attributes that are inherited from certain other classes, of which this is a subclass of. You see the attributes. You see what is the expected value range of each of the attributes. So some of them are literals, right? So text or numbers or URLs. Some of them are objects, right? So pointers to other things, right? In this case, for example, a local business might have an address, which is itself a complex object, because an address has, again, multiple attributes, multiple fields that need to be filled in. And you can have this, of course, in different languages. So thanks to Yandex, there's a Russian guide to schema.org, which specifically explains also how this is being used by Yandex currently. There's also a very cute video with lots of snippets. And the other way, of course, to look at this is to get the actual formal description of the ontology. So you can take such an OWL description. OWL is a standard schema language used in the Semantic Web. So you can process that further in tools. For example, you can load this ontology into an ontology editor and browse the schema in that way. The schema is fairly large already. So I think we're currently somewhere around 300 classes. So 300 classes, I don't know exactly the number of attributes. Not all classes have unique attributes, so some of them are really just types, for example, types of places. But a good number of the classes have a good number of attributes. So it's getting to the point where actually, you would want to search over the schema, or you would want to load it in a tool to look at it. Okay, so this is really the current state of what people do with this data, right? The kind of examples that I mentioned. This data is used to create enhanced results. I did not show you particular examples from vertical search, but for example, Google is already using the recipe markup in their recipe search, right? So when you go to the recipe vertical, some of the data is actually coming from pages that have been marked up for recipe content. And then some of the things that we do at Yahoo, I mentioned, vertical intent search is this related entities suggestions that you see on the left rail currently on Yahoo search. What people report is positive SEO effects. So people have measured increases in click-through rates and all of that. From a research perspective, what we have done is that we have collected evidence to show that this actually helps users to distinguish between relevant and irrelevant results. So this is a paper that I've published with my colleagues at SIGIR last year, 2011. So the paper is titled "Enhanced Results in Web Search." If you want to look up that paper. Okay. Of course, there's plenty of research work here still to do, right? So some of this is now common practice in search engines. Some of this is still in research phase. If you're interested in the research aspect of this, what I would encourage you to do is to look at the various semantic search workshops that people have organized. I've organized a number of workshops as well. The different main conferences in information retrieval in Semantic Web, the World Wide Web Conference, where some of the works are published. These works relate to how to crawl data, how to index, build efficient index structures for RDF data, how to perform the ranking in various settings, in keyword search, in natural language search, in hybrid search, where you have part of your query specified in a formal query language, part of your query specified as keywords, trying to come up with ranking algorithms. Searching over annotated web pages, which is again one of the cases where you have both the textual content and some metadata, and you want to exploit both, right? So you want to combine features from text retrieval, from document retrieval, with features from the structured data graph and how the user query matches the graph. There is at least one competition that is looking at question answering over structured data, over linked data. There the task is to answer full natural language questions using data. There is some work on task completion. So, going back to sort of the holy grail of search, of supporting users in getting some things done, not just giving them results to individual queries, but actually taking them through the process, for example, of buying something from first steps to deciding, to finding the best deal, to actually closing that deal, and to actually collecting the product, for example. The other aspect of this that is interesting is personalization. So once you understand your content at this level, then you can do, of course, a better job at personalization. It's not the case anymore that you're just collecting which keywords your users are interested in, but you're collecting what are the real-world things, the real-world objects that they like. There exists also prototype pure RDF search engines that index RDF data, and they don't index documents anymore, right? They only index either data or metadata. Wanted to show some numbers very briefly. I don't know actually, how much time do you have left? Oh, after me. We're gonna sit here all day. Okay, so I wanted to share some numbers. We're actually very close to the end. The gist of this is that there's a fairly good adoption. I don't know so much about the Russian situation, but at least on the US web, and we published some numbers in a workshop paper at the Link Data on the Web workshop that was held at the WWW conference this year. Some other researchers from Berlin, from the group of Chris Bitter, they also published their own analysis at the same workshop. This one is based on the Common Crawl dump. So Common Crawl is this publicly available collection of HTML pages, and they did the extraction on that dump to see how much metadata is in there. So it's interesting to look at both sources. What you see is that the numbers are fairly impressive. of course, there are different ways to look at it, and when you look at domains, the number is lower, and that's because a lot of the adoption has been among the larger publishers. These large publishers publish a larger number of pages, and also they have a larger coverage in the search engines, right? So more of their pages are in the index of search engines, and that means that in terms of the search engine corpus, there would be a larger coverage than there might be on the overall web. Okay. But just to show some numbers and how they evolved. So historically, I think we've seen something like a 5-fold increase between March 2009 and October 2010. So let's say these are the first year of SearchMonkey, and the second year, and then another 5-fold increase since then, and since we did this last analysis. Okay, so this is really all I wanted to say here. This technology stack that the W3C proposes can be quite daunting, but I think we've seen from a practical perspective that some of these things are fairly interesting in solving problems in search. This means that now, on the research side, the information retrieval community is starting to get involved in this field. We see workshops I already mentioned. We see at CGIAR, for example, this year there's a track on structured data. There's another track on entities. So some of these topics are becoming really current research topics in that field. Okay, and then of course on the commercial side of things, I gave you plenty of examples where search engines like Yandex or Yahoo, we are taking a look at what we could do to improve search using this data. Okay, so that's really all I wanted to say. I hope this will encourage you to either look at using this in the Yandex context, or if you're a researcher, looking deeper into the semantic search field. I probably haven't done justice to all the richness of the work that is going on in semantic search. Okay, so that's really all I wanted to say. Thank you.
Peter, thank you. Now it's time for questions. If you want to ask Peter, please raise your hand and I will give you the microphone. Are there any questions? So, okay, the first question.
It's not a question. I just know statistics about our index. We have about 10% URLs covered by different microdata or RDFa.
Yeah, so I think that's a great number. I think 10% is really a sign that I think webmasters are seeing value from marking up their pages. There is of course a natural let's say a natural collusion of interests in some ways, right? Of course, publishers are interested in helping search engines to understand their pages, and search engines are very interested in trying to understand the content on the web. So there is a natural, collusion in the sense that everyone is interested in making the web searchable, right? That was the title of the presentation, and that is to indicate that really everyone is interested in going in this direction.
So this seminar was broadcasting into Седьмое Небо, and there is another moderator in it, Anton. So Anton,
am I in the way of Anton? Okay.
Anton, are there any questions from the audience in Седьмое Небо?
Yes, do you hear us?
Yes.
All right. I think I've got a question. Well, you see, web search is quite affected by web spam, and how robust and how efficient in this case the microformats and semantic web is? Because currently I don't see any work done into preventing suppliers from providing false data or other kinds of malicious data. What do you think of it?
Yeah, so excellent question. So of course, as you say, you could imagine that, for example, someone having a web shop on the web, selling something on the web, might say a certain price on the page and might say a different price in the metadata, right? So that's the kind of cheating that you might imagine that would happen. Of course, this may happen. I think one part of the answer is that we've already gotten very good as search engine to understand which websites, which publishers are reliable. So in that sense, if this metadata is from a reliable website, then the metadata is also likely to be reliable. So all the work that we have done in web spam until now is still very helpful. In determining whether that metadata is likely to be true or not. The other aspect of this is that since this is data, we can really correlate it with other data. So if we know that price that seller has named is really way too high or way too low compared to what the price of a similar product should be, then we have again a chance to understand that might be a suspicious piece of information. And in that sense, I think we have a better chance of winning against metadata spam than against HTML text spam. Okay.
Thank you.
So it's good that Anton is here. Okay, so maybe we have another question.
Good day. I'm Anatoly Starostin from MB. I have a question like follows. Making the meta information is quite a hard work. It's not very easy for the publisher of the web content to create such information. What do you think about possibilities of creating some kind of semantic factories, some web services which will help people to create this metadata? I can give an example, Open Calais, if you know. Do you think that such services may become popular, and
Sure.
Will they be free or they will be commercial?
Sure. So, probably both. Certainly there are tools already out there that can do some kind of, automated extraction from your web page, and then your job is to just clean up, right? And to correct what might go wrong. And that's in fact, what some of the tools that you mentioned are trying to do. And I also think there is gonna be an industry, just like there's an SEO industry, right? That is helping people to achieve better ranking. This might be either part of that industry or a separate industry that helps people to optimize their site from this perspective, and helps them to do this well, right? So I think professional help is certainly on the way wherever people need it and can afford it, and if they see the benefits, they will spend on making this happen. So yes, certainly people will get help. It's not easy, so I second you, but again, it's not easy to write HTML, right? So how many web pages on the web would actually validate, would actually parse as correct HTML? I don't know the number, but I suspect the number is very low. So another explanation or another answer to this is that probably we as people who are consuming data will get better at dealing with junk. Just like we got very good at interpreting HTML pages that are not even nearly correct, right? And trying to make sense of them anyway. So I think these are some parts of the answer.
Thank you. So you think that today people already see the benefit of the... Yes.
Of course you don't go into the trouble if you don't see the benefits. Yes.
Thank you very much.
And scientifically speaking, the benefit is really helping the user to understand whether that page that they are clicking on, in the case of rich snippets, might be relevant or may not be relevant. And as a publisher, that's of course in your advantage as well. You don't want people coming to your site who are not interested in your site. There is no point in that, right? You really want to appear for the queries and to appear at the right place for the right queries in the case where someone really has a need that is related to what you have to offer. I think that's as basic as it can get.
Actually, we have the agreement with Anton that we will ask questions one by one. So,
okay.
Anton, it's your turn.
Yes, we'll get another question.
Sure.
Yes, so I wanted to ask, how does compares the technology for creating semantic web for private enterprises like huge database holders like Amazon, who have a huge database of content that should be referenced and some kind of semantically linked, and general web that all of the pages on the open internet. What kind of technologies? Do the RDFs and meta tagging do work as efficiently for enterprise?
Yeah. So again, just to clarify the again part of the previous question. Of course, we don't expect people to annotate pages one by one and by hand, right? So most pages on the web are generated from some database, right? Typically, the Linux, Apache, MySQL, PHP stack, right? That generates 90% of the web, right? I just said a large number. We don't expect that people actually manually annotate those pages. They change the code that generates those pages, right? That's what's going on. Now, on the enterprise front, of course, again, you might have databases. You might want to expose them as RDF or convert them to RDF, and there are various tools that people have developed in the semantic web community to help you with that. So this is actually a relational to RDF translation or mapping. There are a number of tools. I can give you some examples later to do that. And in that case, you either convert the data, right? So you do this kind of one-time conversion, or some of these tools implement a layer on top of your relational database that make it appear as if it was a single graph, as opposed to just the relational organization of the data into tables and keys and foreign keys.
Thank you. Back to you.
So my question is. So it looks like the schema.org initiative is really great. It enables many nice features for search result pages and other search services, but still it's conceptual vocabulary. So I mean, it specifies the types of data and relations between these types.
Please speak louder. We don't hear the question.
Hello. Okay. So the question is, do you think it would be useful also to recommend to people to use the so-called instance data sets? So I mean, there are attributes with almost closed number of values. So I don't know, job titles, industries, and so on and so forth. So still in schema and in other ways of marking up the web content, now this is textual information with all these disadvantages of misspelling, synonyms, homonyms, and so on and so forth. So it would be great to reference directly to some data set with a fixed URI with fixed, nicely described data. Yes. So there are nice data sets like geonames, I don't know, Wikipedia, DBpedia. And so do you think it's important, and what's your plans about recommending of using such data sets?
Okay, so this is an excellent question. It allows me to talk about one of the dilemmas or discussions that we have in the schema.org world, and that is to what extent and how far we go in recommending people certain reference vocabularies or certain external data sources. What we do have and in the end we did write this down, is to have a sort of external enumerations mechanisms. And the example, one of the examples is in fact, countries of the world, right? We don't want to, as schema.org, we don't want to maintain a list of the countries in the world, right? Because that's not our job. And there are other sources which are doing a very good job at maintaining a standard list of countries and their identifiers in the world. So what we do in that case is in fact, choose and reference one of these standard sources, right? I can't recall from my head, what it is in the case of the countries, but there is one organization, one standard organization, which does, take up the job of, removing countries, adding countries as they, come online, come offline, right? So in fact, that's one of the dilemmas. Where do we stop, and where do we just point to other schemas and other collections? Yeah.
Thank you.